Hello, welcome to Astronomy, Chapter 8. This chapter is going to be taking a look at the four outer planets. After now, we have taken a pretty close study, a look at what's going on with those four small inner planets. Now, the outer planets and the inner planets, you may remember from a couple chapters ago, are very different from one another. They do have in common the idea that they're large, significant objects all orbiting the sun. But these two classifications of planets are very different from each other. The terrestrial worlds, we said, were small, they're rocky, they're dense, they have a hard outer layer, and they're all very close to one another. Well, the exact opposite happens when we talk now about the outer solar system. These outer planets are extremely large, they are very spread out, they're very low density. They don't appear to have a hard outer surface. They appear to be fluids and liquids. And they all have a ring structure. They all have many moons going around them. And they're all very, very cold. So we have a lot of unique traits for these planets that separate them significantly from the inner planets. And when we talk about the outer planets, we have to start with Jupiter. Jupiter is often known as the king of the planets. It is by far the largest of all the planets. It is also by far the most massive of all the planets. It is a major, major part of the middle of our solar system. Jupiter dominates a lot of area. And we find, Jupiter here is, of course, the fifth planet from the sun. So we've gone from Mercury to Venus to Earth to Mars, now to Jupiter. And Mercury, Venus, Earth, Mars, those four planets all happen in a relatively close distance. That close distance is about 1.5 astronomical units. You may remember from earlier reading about an astronomical unit being the distance the Earth is from the Sun. So this is, Mars is only, those four planets happen in only about 1.5 times the distance from the Earth to the Sun. Well, now we step out 5 times that distance to get to Jupiter. So we have a big step to get to Jupiter. It is much farther away. Right? It's very spread out. Right? And Jupiter is this large, squishy planet with a tremendous amount of mass. Now, this object is known for these layers. One of the things we really look at and see very easily in a pair of binoculars or in a small telescope, you can make out these bands in the atmosphere. And one of the things that we see well is there appear to be these massively large, violent storms going in the upper atmosphere of Jupiter. For example, this red spot here, a lot of these storms, the red spot in particular here, is larger than the entire Earth. So it's effectively like a hurricane that is the size of our entire planet. And they go into some wonderful detail here. They give you a broken down map. If we were to take Jupiter's atmosphere and lay it out like this, we see it looks like these very well-defined tracks, so these bands going through here. And this is created by an effect called the Coriolis effect, where there is a separation. And actually, the Earth does the exact same thing as this, except we just don't have an atmosphere full of different colors of gas. Now Jupiter, which is made largely out of metallic hydrogen, instead of being made out of rock, means that it is squishy. And so there's more material in here that is allowed to swirl and mix as this thing sort of coalesces together. And they go into some great explanation here on talking about how these belts are made. Talking about perhaps a very small rocky core, smaller than the Earth, deep inside. This distance, the diameter of Jupiter is 11 and 12 times the size of the Earth, something like that. And perhaps we think it has a core deep inside, maybe roughly the size of the Earth. But this material is all fluids. It's liquids. It's not a hard outer shell. And that's one of the big differences we see is these metallic layers to it. And the thing, though, one of the major things we know about Jupiter, one of its most impressive traits is its magnetosphere, meaning its magnetic field. The magnetic field of Jupiter is absolutely incredible. It is huge, many times stronger than the Earth's magnetic field. And it has this massive magnetic field. Tells us something about what then must be going on inside of it. It tells us that there must be some sort of powerful engine inside of Jupiter, much like the Earth has. So that is one of the clues we have to looking inside this thing. Obviously, we can't fly into it, but we can kind of sort of look at it indirectly. Now, Jupiter also has a moon system, a very significant moon system, and I'll get to that in a moment. But first I want to touch on its rings. Very few people know that Jupiter has rings, and in fact, we're going to find out all 4 of the outer giant planets have a ring system, like Saturn. Saturn is, of course, the one everybody knows has the massive rings, but all of them have rings. It's just that they are not nearly as easily seen on Jupiter. They're much weaker, much smaller, and much darker than the rings on Saturn. But the thing, though, that I really want to look at, that is a fantastically exciting new area of research, is what's going on with the 4 moons around, the 4 major moons around Jupiter. Now, kind of rewind back several chapters now to the idea of Galileo. Remember, Galileo, way back in chapter 2, looked at the universe with the telescope. And one of the things that he saw was that Jupiter had these 4 moons, very well-defined moons. And if you could do this, you can see these moons with a good pair of binoculars. And a small telescope easily allows you to see these 4 moons. Now, they don't look like this, obviously, in a pair of binoculars. But these are images of what they actually look like. But you can see little points of light dancing around Jupiter from night to night to night, and they move. They're clearly going around Jupiter. And so these moons are known as the Galilean moons. And they are known as such because Galileo discovered them. And because of that, that was one of the major discoveries that led us to understand, to change our understanding of how the world, our universe on a whole, works. But these 4 moons are very exciting because all of these objects are roughly the size of small terrestrial planets. So these are big moons. Ganymede, for example, is the biggest moon in the solar system. And they talk about it by comparison to our own moon, and by comparison, say, to Mercury. Ganymede is almost the size of Mercury. It is huge. As is Callisto, is quite large as well. But these 4 moons are named Io, Europa, Ganymede, and Callisto. And these 4 worlds are fantastically exciting places to think about. And they are relatively new areas of research. But I'll briefly summarize each one of them. Io. Io is very, very close to Jupiter. And Jupiter has a massive gravitational field. And what happens is, as Io goes around in its orbit, it is being squeezed by Jupiter's incredible gravity. It's being squeezed and relaxed, squeezed and relaxed, squeezed and relaxed. And what that does, it is literally squeezing the insides of this planet out, creating tremendous volcanic activity. So this world is totally covered in active volcanoes. Now, Europa may end up being the most interesting of all of these. Because in the year 2013 and 2014, we're looking deeply into the study of Europa, because we know now that Europa has a thick liquid ocean below its surface. That is, the outer surface of this appears to be ice, and below it, ice and rock mix, but lots of ice. And so we think that this basically is like a giant, you can think of it like a frozen water balloon, right? There's ice on the outside, and there almost certainly is liquid water below its surface. And so the real question is, what would happen if we went and we drilled a hole through that ice and started swimming around in that water? What would we find in the ocean of Europa? Very exciting to think about. And someday, I think we will have that answer as to what's down there. But Europa, make sure you read about it. It's a fantastic world. Ganymede, also another exciting place. Ganymede is bigger than Mercury. It is a huge moon. And in fact, if we call it a moon only because it happens to be orbiting Jupiter. But if it were orbiting the sun, it would seem very normal to call it a planet. But Ganymede is very, very large. Large object out there. Callisto talks about it had apparently a huge impact in its past, creating a massive scar around. So make sure you read about those Galilean moons. They are fantastically exciting worlds to study about. Lots of new science to be had about them. All right, let's move on and look at Saturn for a minute. Saturn, the things I want to touch on with it is you see the vital statistics on page 256. We said Jupiter is about 5 times farther away at 5 astronomical units. Well, Saturn is about 10 astronomical units. So we've taken another giant step out, big distance away from the sun. Now, Saturn has all sorts of interesting things about the planet, but really, everybody looks at Saturn and nobody's looking at the planet, right? Nobody pays attention to the planet, right? Everybody's paying attention to these spectacular rings, right? And the ring system around Saturn is just absolutely incredible. And in fact, the ring system was a source of intense study by a spacecraft called Cassini. And Cassini was named for a scientist, an astronomer who was a Frenchman, who studied the ring system of Saturn many hundreds of years ago. I believe, I don't even want to quote the date because I'll say it wrong, but Cassini studied the rings in great detail and even found Saturn's moon. And so that mission was named in honor of him. And the Cassini mission has turned up tremendous information about these rings, about what these rings are, and where do they come from? Why does this planet have rings and none of the others do? The answer to that is very explicitly, the answer to the ring system is because of the moons. The moons are what are creating and sustaining this ring system around Saturn. Because the ring system is not made up of solid material. In fact, it's lots of tiny little rocks and ice. Everything from, say, the size of a piece of dust up to a boulder, maybe the size of, a car or something of that sort. It's a lot of small material is making this up, made largely out of rocks and ice. Now, the moons around Saturn are another fascinatingly exciting world. Titan is the largest moon going around Saturn, and Titan has one very interesting trait. In fact, its trait is that it has an atmosphere. It has a pretty substantial atmosphere. And it's one of the few moons that actually has a real atmosphere to it. Now, this was one of the things that was studied in great detail by the Cassini mission. And what we found out is, if this thing has an atmosphere, we knew this for a long time, but if we knew this has an atmosphere, that must mean something is supplying that atmosphere, which almost certainly means you have to have liquid material on the surface to create that atmosphere. Now, when we sent a probe down, we found out that we think that the surface of Titan is covered with lakes and maybe even small seas of liquid material all over the surface. But it's not liquid water. This is what's really cool. It's liquid methane. Methane is natural gas. And so there's this methane all over the surface of Titan. And this will certainly be an area of more study later on. Now, on page 265, they show you the next couple of moons that are really neat worlds. Really cool places. This is Rhea and Enceladus. And these two worlds are exciting because they are the ones that are responsible for providing material to the rings. And Cassini showed this. If you look closely on 265, you see here these little jets. What looks like a little material being shot off of Enceladus, which is not a particularly large moon, but it is releasing icy material right into that ring system. So it appears that the moons are what's powering those rings. Very, very cool stuff. Okay, moving on quickly, the last two, Uranus and Neptune. Uranus is now where we went from 5. Jupiter was at 5 astronomical units. Saturn's about 10. Uranus is out here about 20. Neptune is out about 30 astronomical units. Very, very, very far away from the sun. So we're seeing these big spread out distances, these large objects many times bigger than the Earth that are out there. Now, Uranus is interesting. The discovery of Uranus was unique because Uranus is the first planet that was actually discovered. This is not visible to the naked eye outside. If you go outside and look on any night over a long period of time, you can see Mercury, Venus, Mars, Saturn, and Jupiter. It should be Jupiter than Saturn. Those 5 planets were the original planetes from the Greeks, way back. Uranus is not visible to the naked eye. Not very well, anyway. It would not be obvious that this is a planet. Neptune, as well, was also discovered. It's even more dim, being farther away. But nonetheless, these 2 objects are very interesting, largely because they're so remarkably similar. They're about the same size. They appear to be made out of about the same stuff. They have a lot of things in common. They have a similar ring system. They have a similar moon system. Uranus and Neptune are very, very similar. But one of the things that separates them is Uranus has a unique trait. That unique trait is shown for you on page 269, and that is that Uranus does not spin like a top. Uranus is laying over and rolling like a barrel. And so that is a unique only to Uranus, as having its axis tilted so far over. But it's a very exciting place to look at, and will be an area of more study in the future. Last one we want to look at very quickly here is Neptune. Neptune, I love this title. It says Neptune was discovered because it had to be there. And actually, Neptune was calculated that it would be somewhere even before we discovered it. How could that possibly be? How could we know where it's going to be if we didn't even know it existed? The answer is, when we looked at Uranus, we found out Uranus had a wobble in its orbit. And so that wobble in its orbit, we figured, had to be created by some other thing out there. Something had to be pulling on it. And we did the math in the 1840s, finding this. We found out that this Neptune was going to be discovered, and was done so. And actually, the discovery of Neptune was tremendously controversial, because both an Englishman and a Frenchman are claimed credit for finding it. And I don't know how much you know about the English and the French in the 19th century, but they didn't exactly get along. But anyway, the discovery, who made it, is not particularly relevant. What matters is, this is the 8th and final planet of our solar system. And it turns out it is a large blue planet, like Uranus. And that blue planet, that blue color, you'll do in the reading, you'll notice, comes from the fact that it is made out of methane. Its ring system down here is shown for you. This is done, we blocked out the light from Neptune, so you could see very faint rings going around them. It's a very exciting world. Something else that I want to point out about Neptune here, and we'll kind of wrap this chapter up, is talking about it has a large significant moon as well, called Triton. Triton is another place that appears to have a frozen lake on it, that perhaps has liquid water on it, and is an area that, maybe we would go there and find life there as well. And so that's one of the unique things that we see about these outer planets. The planets themselves are extremely different from the Earth. They're a totally different type. Big, squishy, cold. But the moons that they harbor perhaps are potential abodes for life as well. Fantastically cool stuff to think about. And sure, as time goes on and we do more studies, we'll learn more about what might be like on those moons as we get out there. So make sure you're keeping up with the reading. In these videos, I'm not covering anywhere near enough to get you through this. You need to be doing the reading. Make sure you check out the PowerPoint associated with Chapter 8 here, and you should be ready to get going on that homework. Good luck.